In part four, we left off with the aluminum carbonate. We'll pick up there. Percent compositions are easy as long as you know the formula. You have to know aluminum carbonate first, where aluminum, this is a metal, that is a AT ending, so it's a polyatomic ion. So aluminum is Al plus 3. Carbonate, we'd have to look up on that chart, CO3 2 minus. Since the charges don't match up, we crisscross and it would be Al3. So there's 3 aluminums, and then there's 2 carbonates, C parentheses CO3 with a 2. You would end up doing the same thing. There's your examples. So that's to find percent compositions, which we can use to find the actual formulas. It's basically going the opposite way. So what you have to find is either empirical formula or molecular formula. Empirical formula is the lowest whole number ratio, which all ionic compounds already are. Molecular formulas don't always have the same empirical formula, which means you can factor those is a good way to do it. So, as we say, benzene, which you don't have to know how to name that one, but 6 carbon 6 hydrogens, that can be simplified to 1 carbon and 1 H. So this is the molecular formula, multiple of 6, and the empirical formula would just be 1 C and 1 H. So if you look at ionic formulas, NaCl, notice we already simplified them, so you don't have to simplify any of those. Those are all empirical formulas. But a molecular compound, H2O, guess what? I can't factor that. So the molecular is still the empirical formula. Glucose, C6H12O6, I can take a 6 out of there. So the empirical formula becomes 1 carbon, 2 hydrogen, and 1 oxygen. And then I can't quite take anything out of there. It looked like evens, but then you had 11. So the molecular is the empirical. If I want to calculate the empirical formula, these types of problems are going to give you the percent composition already. So it's like an opposite problem of that. 3 steps. Number 1, you take the percent they give you and just change the unit to grams. So 74, you don't have any calculations to do. Just literally take the percent, change it to grams. Then convert grams to moles, which we did in the first segment. So I have to, it's going to always be the same. I'm starting with grams, divide by what's on the periodic table, the molar mass, and then find the lowest whole number ratio. So if we go through an example, they give you the percents already, so you already know it's going to be an empirical formula. Take the grams, change it to percents, divide by the molar mass. So I'm going to take the 38.64%, change it to grams, divide by 12 because that's on the periodic table, I get 3.22. Do the same for hydrogen, nitrogen. Now the third step is pick which one of those numbers of moles is the lowest. This will allow me to come up with the lowest whole number ratio. So 3.22, I'm going to divide everything by 3.22. That becomes 1. That becomes 1. And then as we flip through, the hydrogen became 5. So you get C1H5N1. There's an example for caffeine. The percentages you find of each one, find out what the formula of caffeine is. You can do the same thing to find a molecular one. The only difference is they're going to give you the lowest whole number ratio already. So they're going to tell you what the molar mass already is. That is your multiplier. So as you can see, empirical molecular went a little bit faster. If you have any questions, feel free to email mark.boer@addisonschools.us. And don't forget to look at the videos. There's example problems throughout the full PowerPoint and everything. So have a good week, and we'll see you the next week.